Next time you walk into a massive sports bar on a Sunday, and you look at that wall of 60 televisions playing 60 different games, behind the drywall, there isn't just some simple tangle of HDMI cord.
No, definitely not. It's practically a military-grade data center processing billions of bits every single second.
Exactly. And today, we are taking you on a deep dive into that exact hidden ecosystem of high-end AV distribution that basically powers our modern visual world.
Yeah, and we're using the massive HDTV Supply catalog as our map today.
Right, starting with this one very specific piece of gear, the Atlona HT-DSCV1-70-TX Discovery 1 transmitter. Like, just exploring how this unseen infrastructure actually works.
It really is an entire hidden industry. I mean, when you look at the source material, the sheer scale of the hardware needed to move ultra-high-definition video around commercially is just, it's staggering.
It completely shatters the consumer idea of just, plugging a cable into the back of your TV.
Right.
And that really starts with the core technology dominating this catalog, the Wolfpack matrix switchers.
Oh yeah, the Wolfpack systems.
We are talking about modular switchers that scale up to massive 160 by 160 configurations. I was doing the math on that, and it's like 25,600 possible connection paths happening simultaneously.
Which is incredibly hard to wrap your head around.
It is. So, I'm picturing this as a giant digital train yard. You have these massive 4K and 8K video signals. They're the high-speed trains. And the matrix switcher is the central dispatch, making sure every train gets to the right platform without crashing.
Well, it's a great starting analogy, but we actually have to push it a bit further because of the sheer physics involved.
Okay, how so?
You mentioned 8K video. Moving an 8K signal requires a monstrous amount of bandwidth. So if those were actual trains, they'd literally be too wide for the tracks.
Which actually brings up something in the source that confused me. It says these switchers are routing 4K and 8K signals over standard CP6 cables. That's just a regular skinny Ethernet wire, like the one you plug into a home internet router.
Exactly the same wire, yeah.
Yeah. So how on earth does a network cable carry an uncompressed 8K video feed without instantly melting down?
Well, that's the thing. It doesn't carry it uncompressed.
Oh, really?
Yeah, that's the secret of how the train yard actually works.
Right.
The transmitter, like that Atlona one you mentioned, and the switcher, they actively compress the massive video feed into tiny, manageable data packets.
Okay.
Then it shoots those packets down the CT6 cable at the speed of light and perfectly decompresses and reassembles them at the TV in just a fraction of a microsecond. The hardware is, actively managing the timing so packets never collide.
Wow. Okay, that makes so much more sense. It's essentially tearing the train apart, shipping it in tiny identical boxes, and then perfectly rebuilding it on the platform in real time.
Exactly. And if the timing is off by even a millisecond, the football game on screen just freezes.
Which would cause an absolute riot in a sports bar.
Completely. Which is exactly why you see such a heavy focus on sports bar TV systems in the catalog.
Right.
And they have all these custom video wall processors. They offer everything from simple 1x2 screen setups to these huge 10x1 layouts.
And they feature multi-viewers doing PIP and POP, right?
Yeah. Picture-in-picture or picture-on-picture, just seamlessly tiling different games onto one display.
But wait, if this system is doing like billions of microcalculations a second to prevent packet collisions, how does a busy bartender actually control 64 TVs?
It sounds impossible, right?
Yeah, I mean, they don't have a PhD in network engineering.
And they don't need one.
Yeah.
That's where the software hides all the complexity.
Huh.
The catalog lists a whole suite of abstraction layers.
Like what kind of layers?
Well, you have Wolfpad Touch tablets, basic iOS and Android apps, and web GUIs, which are really just simple dashboards you access through a regular web browser.
Okay, that sounds pretty user-friendly.
It is. And then for the really heavy-duty stuff, they use RS-232 and TCP/IP.
Meaning what, exactly?
It just means the system can be securely managed over a dedicated serial cable or a standard computer network.
Ah, got it.
So in practice, the bartender just taps a team's logo on an iPad. Behind the scenes, the software translates that single tap into thousands of complex writing commands instantly.
So it's foolproof on the front end, bulletproof on the back end.
That is the perfect way to put it.
Which completely explains the institutional scale of this hardware. Like, if it can flawlessly handle 64 live NFL games, it makes perfect sense that the government uses this exact same architecture.
Oh, absolutely.
Because the catalog has this massive government purchasing section.
It's basically a mission-critical utility for them. The source notes these products are purchased through the federal GSA schedule, and they're TA approved, and they're even bought via the NASA SIP program.
Okay, let's decode that for a second. I know NSA is a huge government IT procurement contract, but what does TA approved actually mean in this specific context?
So TAA stands for the Trade Agreements Act.
Okay.
It legally mandates that the equipment is manufactured in the U.S. or in countries the U.S. implicitly trusts.
Oh, that makes sense. Because for like a military command center,
Yeah,
you can't have video switchers that might have foreign spyware baked into the chip.
exactly. It's a very strict legal requirement. You literally cannot install it otherwise.
And when you look at their strategic partners, brands like Bose, Dell, Canon, Epson, and Shure, it really hits home.
Yeah, all the big players.
AV distribution isn't some niche hobbyist industry. It is a heavily regulated, highly secure backbone of modern communication.
It completely changes how you look at a simple screen, doesn't it?
It really does. So for you listening, the next time you see a massive, perfectly synced video wall, you'll know all about the vast ecosystem of transmitters, Wolfpack switchers, and invisible data packets making it happen.
Hiding right there in plain sight.
Right. But it does leave me wondering, as we push the physical limits of bandwidth with 8K and beyond, will the future of video distribution stay tethered to these massive physical switchers and SECTs cables? Or are we inevitably moving toward a completely wireless, cloud-based visual world where all this hardware just vanishes? Something for you to mull over until our next deep dive.